So, good morning to all of you students, and today we shall start with how to determine the change in length for compound bars. Can anyone tell me what are compound bars? Yes, compound bars. So, compound bars means bar made up of different materials. Maybe it is made up of different materials, or it may be made up of different diameters, right? I shall draw here one sketch for compound bars. Suppose this is a section, this is made up of one material, right? Then so if you look at this bar, it is made up of different materials and the diameters. This is the front view, right? This is the front view, but this is circular in section with varying diameters, and the compound bar is made up of different materials. To this compound bar, if suppose axial pull is given, right? So this axial pull is P here. This is axial pull P. Now our main aim is to determine the total change in length, that is delta L, because of this axial tensile pull P. What will happen because of axial tensile pull? Definitely there will be some elongation. Because of this pull P, stresses will be developed within the compound bars. Different types, means magnitude of stresses will be different in different types of bars. Assume that this is first section, this is second section, this is third section, and all these sections are made up of various materials. You can say copper, brass, aluminum, whatever it is. So we will assume first of all the length of this first section as L1, length of this second section as L2, and length of this section let us assume L3. I shall explain you how to determine the change in length. Then you can take numerical values, you can refer any book and you can solve the numerical. Assume that area for this first section, suppose A1, for second section it is A2, and for third section it is A3. So in my previous lectures we have already discussed that change in length delta L. Can anyone tell me the equation for delta L? Change in length delta L equals to, what is the equation, students? We have derived Young's modulus is equal to stress upon strain. Stress is P by A, strain is delta L by L. So E equal to P by A upon delta L by L. So delta L equal to, finally we have arrived to this, delta L equal to PL upon A. Such types of numericals are very simple, and in GATE exam you will get such types of objectives. So PL upon AE is the change in length. So for first section, if you will try to calculate delta L1, what will be delta L1 for this compound section? It will be P, this axial pull is same for all these sections, P into L1 upon A1 PL1 upon A1 into, if this compound bar is made up of same material with varying diameters, right? It is also called as compound bar, but E value will remain same. And if materials in these sections are different, then E modulus of elasticity will also be different. So let us assume that these sections are made up of various different materials. So it will be equal to E1. Same way, you can calculate the change in length delta L2. This axial pull remains same, P into L2 upon A2 into E2. If this compound bar would have been of same material, you would have used only E value. As here in this case it is made up of various metals, so we are using E1, E2 and so on. Area you can calculate very easily, as these sections are circular in shape. If you know the diameter, right, pi by 4 into d1 square will be equal to A1, pi by 4 into d2 square will be equal to A2, pi by 4 into diameter, you know, you can calculate A3. So in this way you can calculate the various change in lengths at different sections. So this is delta L3. Can anyone tell me how to calculate the area of circular section? Can anyone tell me?
Sir, pi r square.
Pi r square. Okay. And r equal to d by 2. So pi by 4 into d square. Right? So P, this is length L3 upon A3 into E3. So in this way you can calculate delta L1, delta L2, delta L3, and finally total change in length delta L will be equal to delta L1 plus delta L2 plus delta L3, and finally you will get delta L equals to something. Either you calculate in meters or you calculate in millimeters, whatever it is, you add up the units. So you need not to get confused how to calculate the change in length in case of compound bars, right? You can practice, take the value of axial pull P as 150 kilonewtons. You can practice one numerical I shall give you. You can practice the value of P. You take 150 kilonewtons. Diameter of this section you take, suppose 40 mm. Diameter for this section you assume say 20 mm. Diameter for this section again you assume say 45 mm. Right? Length, you assume that this section is of length 150 millimeters. You can take this as 200 millimeters. You assume this length as 250 millimeters. So in this case you have all the values. Now while practicing this numerical, you assume that this compound bar is made up of one single metal, say iron. So you assume the value E. You assume any value, or if you are not assuming but E will be same for all the sections, so whatever the change in length you will get here, P you know 150 kilonewtons, length you know, area you can calculate, so you will get change in length in terms of E. If value of E is not given, right, and objective is asked in GATE exam, so you clearly calculate these values and you will get the change in length in terms of E, no problem. If suppose, next variation, if suppose the total change in length is given, the total change in length of this compound rod is suppose 0.5 millimeters if it is given, and you are asked to calculate the value of E, then what you will do? Again the same equation you will apply, delta L1 equal to P 150, L1 you know, A1 you know, E you have to calculate, delta L2 P 150 kilonewtons, L2 you know 200 millimeters, you have to adapt same units, divided by area you can calculate from diameter, again into E you have to determine, delta L3 equal to P you know, L3 you know, A3 you know, E you have to calculate. Then total change in length is 0.5 millimeters. So in place of this delta L, you substitute the value 0.5 millimeters equal to something divided by E. So you can calculate the value of E if total change in length is given. So in compound bars, students, these are the 2-3 variations which you have to deal. Is this clear to all of you? So I think the concept of calculation of change in length in compound bars is clear to all of you. Thank you. Thank you very much.